Buckle up, because today we are connecting three massive stories into one. Google just linked Gemini directly to live Google Maps data, so artificial intelligence answers can now use real-world information. Manus 1.5, a next-generation agent, now builds and deploys full-stack web applications almost 4 times faster than before. And Nvidia, together with Taiwan Semiconductor manufacturing company in Phoenix, has unveiled the first United States-made Blackwell wafer. It is a 208 billion transistor chip that is powering a new wave of American-made artificial intelligence hardware. Here is how it all connects and why it matters for the applications you build, the agents you run, and the chips that make it all possible. Let us start with Google. As of October 17, 2025, grounding with Google Maps is live in the Gemini application programming interface. James Harrison from GeoDeveloper and Elisa Fortin from Google DeepMind explain that developers can now connect Gemini reasoning power with live geospatial data from more than 250 million places. The model automatically detects when a question has a location context and pulls accurate details like addresses, hours, ratings, reviews, and photos straight from maps. If you want to localize results, you can include coordinates. The documentation even shows Los Angeles coordinates, latitude 34.050481 and longitude -118.248526. To anchor a prompt, like, what are the best Italian restaurants within a 15-minute walk from here? The response can return grounding data and a token that lets you show a real Google Maps widget inside your application. That widget includes photos, reviews, and full place details. So you are not just telling users what is nearby, you are showing them visually. Integration works through the Gemini Generate Content call with Google Maps enabled as a tool. It is supported across Gemini 2.5 Pro, Gemini 2.5 Flash, Gemini 2.5 Flash Lite, and Gemini 2.0 Flash. In Google Artificial Intelligence Studio, there is even a live demo powered by Gemini Live. One example query asked for Italian restaurants in Chicago, misspelled a name, and the model corrected it using Maps data before returning correct business hours and reviews. You can combine Maps grounding with search grounding in the same request. Maps provides structured details like addresses and hours, while search brings in context like events or recent news. Google says this combination gives significantly better results. Pricing starts at $25 per 1,000 grounded prompts, so it is best to use the feature only when the query really needs geography. The tool is available globally, except for a few regions like China, Iran, North Korea, and Cuba, and it cannot be used for emergency response. Developers must also include proper source links and attribution back to Google Maps. Now let us talk about Manus 1.5, which launched on October 16th. This new version delivers big improvements in speed, reliability, and quality. Tasks that used to take 15 minutes in April now finish in under 4 minutes on average. For complex jobs, Manus can assign more reasoning time and computing power instead of failing. Internal tests show a 15% boost in task quality and a 6% rise in user satisfaction. It can also handle much longer workflows thanks to a larger context window that keeps everything consistent. The biggest new feature is full-stack web application development directly through conversation. Manus can now build complete applications from front-end to back-end. It creates the server infrastructure, user authentication, and persistent databases. It can also embed multimodal artificial intelligence and image generation directly inside the application. Other built-in tools include event notifications by email or an application, natural language visual editing, custom domain publishing, analytics for visitors and traffic, version control with rollbacks, and permission settings for private or public access. With its integrated browser, Manus actually launches and tests the applications it builds. It clicks around like a real user, finds bugs, and fixes them before you deploy. You can invite team members to collaborate in shared sessions, and the new library keeps all your generated files organized. Manus 1.5 Lite is available to everyone now, and subscribers to the full version get a 50% discount on Lite credit use. Now for the hardware that drives all this progress. On October 17th, Nvidia revealed the first United States-made Blackwell wafer, produced by Taiwan Semiconductor manufacturing company in Phoenix, Arizona. This marks a major step bringing artificial intelligence chip manufacturing back to the United States. Nvidia said the goal is to strengthen the supply chain, localize production, and secure American leadership in the artificial intelligence era. Taiwan Semiconductor Manufacturing Company, Arizona fabs are producing advanced 2, 3, and 4 nanometer chips, including the A16 line used for artificial intelligence, telecommunications, and high-performance computing. The Blackwell chip itself is a monster. Built with Taiwan Semiconductor Manufacturing Company 4NP process, it contains around 208 billion transistors, about 2.5 times more than the previous Hopper generation. It uses a dual-die design connected by a 10 terabyte per second NV high-bandwidth interface, so the two chips act as one. It introduces FP4 precision, which doubles performance and memory efficiency for large artificial intelligence models while keeping accuracy high. The new transformer engine speeds up large language model inference by up to 30 times compared to the H100, and a decompression engine moves data at 800 gigabytes per second, roughly 6 times faster than Hopper. The 5th generation NVLink provides 18 connections per graphics processing unit for up to 1.8 terabytes per second of bandwidth, and can link as many as 576 graphics processing units in one domain. Using the NVLink switch, the total graphics processing unit bandwidth can reach 130 terabytes per second. Overall, Nvidia says training is up to 2.5 times faster and inference up to 30 times faster, with 25 times better energy efficiency for some workloads. Big technology companies are already lining up. Amazon Web Services, Google, Meta, Microsoft, Oracle, OpenAI, Tesla, and xAI have placed major orders. Analysts say Blackwell chips are sold out well into 2025. Nvidia plans to invest up to $500 billion in United States artificial intelligence infrastructure over the next 4 years. They are building large-scale artificial intelligence factories and new supercomputer assembly plants with Foxconn in Houston and Wistron in Dallas. Dell has already unveiled new PowerEdge XE9785L servers designed for Blackwell. Advanced chip packaging, known as CoWoS, still happens in Taiwan for now, but Amkor is building a $2 billion packaging facility in Arizona to bring that step to the United States. The competition is still intense. Advanced Micro Devices is working on its MI300 and MI450 graphics processing units. Intel is expanding its foundry services, and companies like Google, Microsoft, Amazon, and Meta are building custom chips. Manufacturing in the United States costs about 35% more than in Asia, and there is a shortage of around 67,000 skilled workers expected by 2030. Energy demand from artificial intelligence data centers could reach 12% of all United States electricity by 2028. But most experts say the trade-off for supply chain security is worth it. Nvidia roadmap continues with Blackwell Ultra in late 2025, which should be about 1.5 times faster. Rubin, arriving in 2026, will introduce new architecture with HBM4 memory and NVLink 6, followed by Rubin Ultra in 2027 with 1 terabyte of HBM4E memory and 4 graphics processing unit dies per package. Taiwan Semiconductor Manufacturing Company has already started high-volume 4 nanometer production in Arizona and is moving faster on 2 nanometer and 3 nanometer fabs by the end of the decade. The artificial intelligence chip market is valued at around $150 billion this year and is projected to pass $400 billion by 2030. Policy, export controls, and supply diversification will play huge roles in how that growth unfolds. So here's where we stand. Artificial intelligence is now grounded in real-world data through Google Maps. Agents like Manus 1.5 can build complete applications in minutes. And United States-made Blackwell chips are bringing massive compute power home with 208 billion transistors, 1.8 terabytes per second bandwidth per graphics processing unit, and 10 terabytes per second between dies. Together, these advances point to faster, smarter, and more reliable artificial intelligence systems built on home soil. Thanks for watching, and see you in the next one.